Hi, in this video we'll discuss scopes. To start with, what is scope? Well, simply put, scope is the part of your program where a variable is visible. Generally, there are 4 scopes in Python: local scope, non-local scope, global scope, and built-in scope. Local scope is where the variable is created. If the variable is created directly in the module, then the module is its local scope. If it's created in a function, then the function is its local scope. If we define a nested function, and inside the nested function we define a variable, then the nested function is the variable's local scope, and the enclosing function is the non-local scope. Have a look. Here we have a function, f_enclosing, and a nested function inside the enclosing function. Here, y is in the local scope of the nested function, and x is in the local scope of the enclosing function. At the same time, x is in the non-local scope of the nested function. The general rule is that in local scope you have access to non-local scope, but not vice versa. So in the nested function, x is accessible, but y is not accessible in the enclosing function. Let's have a look. Here in the nested function, we're trying to access x, which is in non-local scope. Well, let's run it in interactive mode. And now let's call our f_enclosing function. The output is 15, so it worked. X, which is 10, plus 5 is 15. So as we can see, in the nested function, we have access to a variable defined in the enclosing function. And now let's try to access y in the enclosing function. Let's run it in interactive mode. And let's call our f_enclosing function. Name error. Name y is not defined. So it doesn't work that way. So to sum it up, in the nested function we have access to non-local variables, so variables defined in the enclosing function, but in the enclosing function we don't have access to variables defined in the nested function. Although we can nest functions at as many levels as we want, it generally isn't good practice. The code gets difficult to read. Anyway, just theoretically, imagine a hierarchy of functions like that. Enclosing, nested level 1, nested level 2, nested level 3. Well, w is local in the level 3 function. Z is local in the level 2 function. Y is local in the level 1 function, and x is local in the enclosing function. Inside the innermost level 3 function, z, y, and x are all in non-local scope, and if the program has to find them, the search goes in the direction from inner to outer. Well, this looks awkward, so it should be avoided. One level of nesting is quite common, but we shouldn't use more levels of nesting for the sake of our mental health at least. Then we have global scope. If a variable is defined directly in a module, it's in global scope. Have a look. Here n is in global scope, which at the same time is the local scope for the module. X and y are defined in the functions, here and here. We can access variables defined in global scope from any function at any level of nesting, so n, defined in global scope, is available here and here, inside the enclosing function and the nested function. It's global, which means accessible in the whole module. But again, we can't access the variables defined in the functions from global scope. So let's run this code in interactive mode, and let's call our f_enclosing function The result is 30 and 25. So 30 is the output from this print function, x plus n, 10 plus 20, and 25 is the output from this function, y plus n, 5 plus 20. So it works, and the global variable n is accessible inside the functions. And now let's try to access the variables defined in the functions from global scope. For example, print n plus x. We get an error, name x is not defined. Okay, and now let's see what happens if we have overlapping names. Here's an example. X equals 5. This x is defined in global scope, and now let's define a function. Def func x equals 2. So here we have x defined inside the function. Print x. Now let's call our function and let's print x. So here we have the variable x in global scope, which is assigned the value 5. Then in local scope, x is assigned 2. If we use a variable with the same name as another variable in a function and assign a value to it, we're not changing the global variable, but instead we're creating a new local variable. From now on, only the local variable is accessible in the function, which means here it will print 2, not 5. But in global scope, we still have our global variable x equal to 5. And now these two x variables, this one and this one, are referencing two different objects. Now let's run this code. The output is 2 and 5 as expected. So this function printed 2, which is a local variable x defined over here, and then we printed the x defined in global scope, which is 5. So we have two different objects here. And now let's modify our example slightly. We know that inside the nested function, we have access to variables in local scope, in non-local scope, and in global scope. So if we use the x variable in the nested function without assigning a new value to it, we're not creating a local x variable there. Now the question is, which one will be used inside the nested function? The one from the non-local scope or the one from global scope? In other words, print x. Which x will be printed here? 2 or 5? Let's check it out. 2. So it turns out the non-local scope wins. This is because the order in which the scopes are searched is local, if not found there, then non-local, if not found there, then global, and finally, if not found in global, then it's searched in the built-in scope. Finally, let's have a look at the built-in scope. All the built-in objects, like functions, exceptions, and so on, are defined in this scope, and this scope is used as a last resort if a variable is not found in the local, non-local, or global scope. We can use the objects defined in the built-in scope out of the box, but what if we define a variable with the same name in another scope? Let's see. In the built-in scope, we have the function len, which is used to return the length of a sequence. Now let's define our own len function in global scope. Def len x return * space times x. And now let's use our function. As soon as len is defined in global scope, it is a new global object, and from now on this object will be referenced instead of the built-in function whenever it's used. This is because when we now use the len function, it's first looked up in the local scope. If it's not found there, the search moves on to non-local scope and then to global scope, and there it is found. The search is over and the built-in scope is not looked up at all. Well, redefining objects from the built-in scope is a good way to break the references to built-in objects, so use it sparingly if you really have to. Now, is there a way of accessing the global variable from inside a function? Actually, there is, but this is a topic for another video. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.